In this video, I'm going to explain quadratic inequalities. A quadratic inequality, here it is given as a definition, inequality that can be written only in the forms greater than 0, ax squared plus bx plus c is greater than 0, or less than 0, or greater or equal to 0, and the last one is less or equal to 0 it's going to be. Here, of course, it shouldn't be equal to, if you remember, a shouldn't be equal to 0. If a is equal to 0, then this is not quadratic inequality, it's going to be. Okay, then what we are going to do, we have to follow some steps for that one. Firstly, if ax squared plus bx plus c is equal to greater than 0 or less than 0, there is no importance, we have to make one table for that one. This table represents the linear real number line. On the left side we have minus infinity, it goes to minus infinity. On the right side we have it goes to plus infinity, and x1 and x2, they are representing the roots of the inequality. And if you remember how to find the roots, when ax squared plus bx plus c is equal to 0, and then we were finding x1 and x2. These are representing that x1 and x2. These are the roots of. And then we are going to put here plus or minus signs. Here there are three places for the quadratic equations. We are going to put the signs of the inequality. Also here I need to explain, of course, if there are two roots, it's meaning that delta must be greater than 0 also. Delta is equal to 0. There is only one root, so we are talking about when delta is greater than 0. When delta is less than 0, there is no real root, so we cannot draw this table like this. But for the we are talking now, we are going to solve the questions with respect to that one. Then we are going to look at the signs of the quadratic inequality with respect to signs. If it is greater than, we are going to take the pluses. If it is less than, we are going to get the minuses. I'm going to try to explain on the question again this one. Okay. We are going to continue with these questions. First, I'm going to solve the question here, and I'm going to explain which steps we are going to follow. Of course, first let me write firstly x squared minus 5x plus 6 is greater or equal to 0. So I'm going to find where the function is greater or equal to 0, or when it is greater than 0. X squared minus 5x plus 6. I'm going to analyze when it is greater than 0, when it is less than 0. And for finding this one, firstly I need to find the roots. So for finding the roots, I need to say x squared minus 5x plus 6 when it is equal to 0. Okay, I'm finding x squared minus 5x plus 6 when it's equal to 0. I'm finding x1 and x2 here, and I'm going to write x1 and x2 here. And this is only part of the solution. It is not going to show me greater than or less than equal to 0. It's going to show me only the points, and when I say here it's equal to 0, it is not the question. It is solution helpful part for the solution it's going to be. If you remember x squared minus 5x plus 6 when it's equal to 0, if it is possible to factorize, we were factorizing like minus 3 and minus 2. I'm going to say minus 3 times minus 2 is equal to 6 plus 6 minus 3 and minus 2. When you add them, it's going to give you minus 5. So minus 3x, so it's going to be minus 2x. That's equal to, the sum is going to be equal to minus 5x. If you get the midterm, it means that your factorization is true, and your x1 and x2, we are going to find x1 and x2 now. x minus 3 times x minus 2 is equal to 0. It means that x1 is equal to 3 and x2 is equal to 2. It's going to be so. Here x1 and x2 I'm finding like this one, but when you're writing in real number, because this side should represent minus infinity, this side represent plus infinity, I need to be careful about real number order. That's why I cannot write 2 on the right side. 2 is less than 3, so it should be in this one. Now I'm going to continue with the signs of the I'm going to continue science of the table. Here I have divided the table into 3 parts. When you find 2 roots in real number line, you are dividing the table into 3 parts. Then here I'm going to start with plus, then minus, then plus. It's going to be. How it's going to be plus? When you check the sign of the x square, if it is plus, then this expression, it starts with plus. On the left side, when you continue 1 minus, 1 plus, 1 minus, 1 plus order, it's going to be. So these are the roots of the equation, and we start with plus because the sign is plus here, then 1 minus, then 1 plus, it's going to be. If it is minus, if this sign is minus, we will start with minus, then plus, then minus. It's going to be 1 minus, 1 plus order. It's not going to change. Okay, I found the plus and minus values. Then in the third step, I'm going to shade the pluses with respect to, if it is greater or equal to 0, I'm going to shade the pluses, and if it is less or equal to 0, I'm going to shade the minuses. Here, greater or equal to 0 and less or equal to 0, of course it should be at the same time greater than 0 or less than 0 must be included to these cases. Here it is greater or equal to 0, that's why I'm going to shade the plus ones. Here I'm going to shade these plus sides. Here like this I'm going to do. So this is our solutions it's going to be. And with respect to this one, I'm going to write solution set. Which part is shaded? If I ask you, you will easily say me between minus infinity and minus 2, minus infinity and 2, sorry, and 3 and infinity, it's going to be. Now I'm going to make this one as a set form, as an interval form. Here it is greater or equal to sign. That's why I'm going to close this one. And here, this one also, it's going to be closed. And infinity side is always open, it's going to be. So this expression, it's going to be in this one. And when you're writing the set form of this one, solution set, it's going to be equal to x such that x is element of minus infinity to union 3 to infinity. It must be for this question. Okay, for the second question, I'm going to get another step here because this question is not in this form, in the first form. Firstly, you have to collect the terms to one side, which means minus x squared, or it can be like this, we will collect on the right side, which is x squared, 0 is less than x squared plus minus 5x plus 4, it's going to be. And if I choose here x squared minus 5x plus 4 is greater than 0, it won't be wrong, because actually this one and this one, they are same thing. And for easy operations, it's better for me to do in this form. Then the first step I'm going to apply, I'm going to find the x squared minus 5x plus 4's roots, which is x squared minus 5x plus 4 when it's equal to 0. You will find x1 and x2. I explained that one before. x1, x times x minus 4 times minus 1, it's going to be. And the sum is minus 5, so the factorization is true. I don't have this space here, I'm not going to do like this, but you will understand from the solution because we solved many questions like this. So x minus 4 times x minus 1 is going to be equal to 0 firstly, and then x1 is equal to 4, or x2 is equal to 1, it's going to be, and in the real number line 1 comes before then 4, that's why on the left side 1 it's going to be, on the right side 4 it must be. Again, I'm asking the sign of the x squared here. I'm going to ask the sign of x squared because if I put here plus sign, I mean actually this is plus sign, I knew that this is plus sign, so your graph starts from left to right, it should be also from left to right it's going to be, and it starts with plus sign, then minus, then plus. If there is one more, it's going to be minus. But the function has only two roots. That's why we are going to do in this form. Then this is going to be here. Which function I'm analyzing here? X squared minus 5x plus 4. I'm analyzing, and with respect to this one, it says again it is greater than. That's why I'm going to shade the pluses again here. Pluses, this plus and this plus sign. When we shade, these are the solution of the interval. Here this time I'm going to be careful about the greater than sign, because here it is greater than 0, here it is less than 0. It's going to be here it is greater than 0 also, here less than 0, sorry, less than 0, it must be in this form. Then again greater than 0 in this interval, it's going to be, for me, greater than 0 parts are important, so these two, they are the solution of the inequality. Then I'm going to write the sides like this. Let me give a space because here there is one small to remind you about how it was. I'm going to write the solutions like minus infinity minus 1 and 4 to infinity, and minus infinity minus 1, 4 to infinity. It's going to be like this. And if I write the solution set again, solution set, it's going to be x such that x is element of minus infinity minus 1 union 4 to infinity. It's going to be, by the way, for understanding, this side is positive. You can choose one value between 4 and infinity, like 5. When you replace the 5 here, 5 squared minus 5 times 5 plus 4, you are going to see that it's going to be equal to 4, and then it means that the result 4 is greater than 0. That's why this side is positive. If you choose one value between 1 and 4, let's say it's equal to 3, then 3 squared minus 5 times 3, 3 squared 9, 5 times 3 is minus 15, 9 minus 15 is minus 6, minus 6 plus 4, it's going to be minus 2. As you see, the result is negative, so this part it's going to be negative. When you choose one value less than 1, let's say 0, 0 squared minus 5 times 0 plus 4, as you see, it's going to be equal to 4, and it is greater than 0 again, so this side is going to be plus. So with respect to that one, we are going to solve the questions. And at the end, if I want to summarize the things what I explained to you. Here, we are going to follow many steps, but if I skip some of the steps, firstly we need to factorize, then with respect to that one, we are going to make the table. We are going to find x1 and x2. And when you put the x1 and x2 in your table, you're going to start with plus. If the sign is plus or x squared, here you're going to start with minus if the sign is minus for the function. Here I showed something. If your function given in factorized form, like x times something times x, both of them plus, you know, x times x, it's going to be plus. That's what plus x times plus x, it's going to be plus x squared. That's why this again starts with plus. But if one of the form starts with minus x, one of them is plus, then minus times plus, it's going to be minus x squared actually, and your table starts with minus sign. The second part that we have to be careful, when we are, if our function, fx function, ax squared plus bx plus c, I'm talking about, if fx function is greater than 0, we are looking for pluses. If we greater and greater or equal to 0, or if it is less or less than 0 or less or equal to 0, we are going to shade the minuses. Then we are going to get the solutions with respect to that one. If it is greater or equal to, less or equal to, we are going to use closed parentheses. And if it is greater than or less than, we are going to use open parentheses. But we should be careful about here. Infinity side always open. So when you see infinity, minus infinity is open. Even the question with greater or equal to, less or equal to sign, it doesn't important for us. It's going to be like this. or positive infinity, infinity open, it's going to be. And with respect to this table and these two, you are going to write your solution set at the end with respect to all these informations.